Hi, in this video we're going to learn how to multiply and divide rational expressions. At the end of the video, you should be able to multiply and divide rational expressions and also remember to simplify your answers, which are the product or quotient. Let's begin with multiplication. The product of two fractions is found by multiplying the numerators and multiplying the denominators. Rational expressions are multiplied in the same way. The product of the rational expressions P over Q and R over S is P over Q times R over S is equal to P times R all over Q times S. That is, to multiply rational expressions, multiply the numerators and multiply the denominators. Let's have examples. Multiply 2 over 7 times 5 over 10. Let's start with your simple arithmetic operations. To do that, you are supposed to multiply 2 and 5, 7 and 10. You can choose to multiply 2 and 5, it becomes 10, 7 times 10 is 70. Or you may choose to apply factoring. 10 is factored as 2 times 5, wherein you could actually cancel now 2 and 5. If everything is cancelled, there should be 1 left. The answer is 1 over 7. If you chose the first suggestion I offered, the trick on cancellation tens is just to cancel 0 and you have 1 over 7. Whatever is your technique, the final answer, the product is 1 over 7. That's your simple multiplication of fractions for your arithmetic problem. Now, let's have your algebra with variables. Multiply 8p squared times q divided by 3 times 9. Multiply to 9 all over p times q squared. To multiply, you just multiply the numerators and the denominators, and then this follows the factoring method. So we will factor everything. There's 2p and then 9 is 3 times 3. There's 2q's and then copy 3p. As you can see, it's already color code. There's pairs of 3, p and q that you could divide out or cancel, and that your answers are the ones in red. 8 still can be multiplied to 3 and you have 24, and your variables are 24pq, and that's your answer. Okay, now there's a note here. It is also possible to divide out common factors in the numerator and denominator before multiplying the rational expression. What it's trying to say is that, let's say you have 9 here, divided by 3, you get 3. But you also do that on another opposite. You have 3 divided by 3 is 1. So ahead, we were able to divide out common factors between 9 and 3, and now it becomes 3 and 1, and that's what you multiply to your other numerator. 1 needs to be multiplied to the other denominator. Okay, or in another way of saying, you could do an advanced cancellation before actual multiplication. Let's have some more examples. Factor and divide out. You have 8x over 21y cubed times 7y squared all over 16x cubed. You can write them all together. Numerators multiply to numerators, denominators multiply to denominators, and now in their factored form. 21 is 7 times 3, 16 is 2 fourths, 8 is 3 2's, 2 times 2 times 2, and then the rest are factored out. And now you start dividing out common factors. There's 3 pairs of 2's cancelled out, 1 pair of x, 1 pair of 7, and 2 pairs of y. Since everything is cancelled on top, there should be a 1 that is left on the numerator. On your denominators, there's 3. Sorry, I need to click another. There's two pairs of y, there's 3 y and then 2 x's, so it's 3y x squared, or by alphabetical order supposed to be you have 3x squared y, 1 over 3 x squared y. Oops, I missed the 2, so that's why it's 6. Okay, let's have another example. Factor and divide out. That's how you actually multiply rational expression. So let's start. What you can do, you can factor out everything, but remember the note earlier, you can do this in advance. Divide both 5 and 15 by 5, you have 1 and then 3. You can cancel out 24 and 12, you have 2 and then 1. And then what you could just have to worry are the variables. But let's deal with the actual work shown here on your PowerPoint. After completely factoring everything, start pairing up the cancellation. Pair of 5 is cancelled, and there's 3 pairs of A, 2 pairs of 2, 1 pair of 3, 1 pair of B cancelled out. The rest are gonna be your answer. You have the A and the C and the 2, so you have 2AC cubed. You have also a 3 and then B squared. Okay, let's have another example. Now you have a complete polynomials, rational expression with trinomials. Same deal, but it's a little more work this time because you need to factor your trinomials. Let's see, factor and multiply, but actually we divide out the common factors. So let's begin. We factored out 2x on the first part, so after factoring out 2x here, what is left factored out is x. If you factor out 2x from 4x, you have 2 left. If you multiply and check, 2x times 2, 4x, 2x times x, 2x squared. Here, the factors we need on the second numerator is actually 9 and 2. No, it's actually 6 and 3. Since 9 is negative, it means both are negative. Anyway, 6 times 3, negative 6, and times negative 3 is positive 18. Next, here we need the factors 6 and 2. Since 12 is negative, 6 should be negative, so that when you add, you get a negative 4. And so you have x minus 6, x plus 2. And then copy 2x. And then start cancelling or dividing out common factors. You have 2x, and then x plus 2, and then x minus 6. Amazingly, we completely simplified our complicated multiplication of rational expression problem. It's only x minus 3, which was the uncancelled. And that's your answer. Okay, let's have another example, and these are more factoring. This is your last example. Let's begin. Here on your first part, we can actually factor out 6 and then x. After taking out 6 and x, there's only 1 x left. After taking out 6, we have 3 here and then no x. So therefore, that's going to be your first result. X plus 3 is left inside the parentheses. On your second numerator, you have a negative 2, actually positive 2, no, actually negative 2 and 1. So that when you add, you have a negative 1 difference. So x minus 2, x plus 1 will be your factor on the second numerator. Your first denominator should be 3 times 2. Since it's positive, 6 should have a factor of positive 3 and negative 2. And then here, you have 8 times 7. No, 8 times 1. Where 8 should be negative, so that negative 8 plus 1 will give you a negative 7. And then, after carefully factoring each part, you can now start canceling your common factors. You have x minus 2, x plus 3, and x plus 1. What is left is 6x on numerator and x minus 8 in the denominator, and that's your final answer. Okay, that's how you multiply rational expression. And these are your challenge problem. Give yourself time to try, and then if you're watching this on your own, pause the video and click play to reveal the answer. And the answer for the first set is x squared y squared divided by 4. The second problem, the answer is x plus 3 over x squared plus 5x. Okay. How about division? Division of rational expression is defined as follows. If P over Q and R over S are any two rational expressions with R divided by S not equal to 0, then you have P divided by P over Q divided by R over Q is equal to PQ times S over R, which is actually equal to PS over QR. That means to divide one rational expression by another rational expression, multiply the first rational expression by the reciprocal of the second rational expression. Reciprocal. What happened here is that the R was flipped. R went down, S went up, the division becomes multiplication. Okay? Remember, always remember, we flip your divisor, your second number, and then change division into multiplication. That's how you divide rational expression. That's also how you do on simple math arithmetic division of fractions. Let's have your example. This is what I'm talking about. The same actually applies to your simple division of fractions. So if you divide 3/4 divided by 5 over 16, what actually happens is that you flip your 5 over 16, 16 goes up, 5 goes down. And then you start the multiplication technique, which is it's either you multiply and reduce the lowest term, or you factor and cancel out common factors. So here we will do the second technique, which is factor your 16, 4 times 4. And then as you can see, we can now cancel your 4. Your answer is going to be 3 times 4, 12 over 5. The same process if it is rational expression. So here you have 9p squared divided by 3p plus 4. The expression is divided by 6p cubed all over 3p plus 4. You're going to flip your 6p cubed over 3p plus 4, and then the division becomes multiplication. If you're not paying attention, actually 3p plus 4 can be cancelled out, obviously. And now you can factor your 9p squared and 6p cubed. And the purples are the ones supposed to be cancelled out. The answer is 3 over 2p. Okay, let's have more complicated problems. Divide 5a squared b over 2. The expression is divided by 10ab squared over 8. Same rules. Flip your second fraction and change division into multiplication. Then you can apply factoring and then cancel common factors. And the answer is 2ab. Okay, the purples are the one that comes in pair and they are cancelled out. The red is your final answer. Let's have more complicated problem. Not yet. I I don't think this is complicated. Let's just try this one. You have 10p x squared all over 3c squared d divided by 5px over 6c d c squared d squared. Flip your second fraction and then change division into multiplication. And then start factoring everything. And then start pairing up your common factors. Your common factors, yes, from between numerators and denominators. So let's see, 5, pair of 5 is cancelled, p, x, 3, and 2 pairs of c, and then 1 pair of d. What is left is the 2 times 2, 4, and then x, d, or by alphabetical order, dx. So you have 4 dx, since everything is cancelled in the denominator, so you only have 4 dx as your final answer. Okay. Now it's getting complicated. 3 over x plus 7 is divided by the expression 8x squared minus 8x all over x squared plus 6x minus 7. Flip your second fraction, change division into multiplication, and start factoring. So let's do this. This one should have a factor of 7 times 1, and 1 is negative, so that it becomes positive 6 when you add your factor. Here we will just factor 8x. After taking out 8x from the first term, you only have 8x here. On the second, you have minus 1 after factoring out 8x. Okay. Next, you can now cancel your common factors. X plus 7 and then x minus 1. The answer is 3 over 8x. Okay. Let's have some more. Maybe this is more complicated. And let's try. 4x is multiplied to x plus 3 divided by 2x plus 1. The whole expression is divided by negative x squared multiplied to x plus 3 all over 4x squared minus 1. Flip your divisor and then change division into multiplication. Amazingly, we can cancel for the x plus 3's. And then we will factor this one. This expression is supposed to have a factor of 2x plus 1 and then 2x minus 1, because it's the case of the a squared minus b squared, a plus b, a minus b. The rest are just basically factoring of a term. So here it is, the 2x minus 1 and then the 2x plus 1. Whichever comes first, it does not matter. So amazingly, the 2x plus 1 from the original given can cancel one of the factor here. So you have 2x plus 1 cancelled out. A pair of x is cancelled out. The answer is going to be negative 4 over x. The negative 1 can be a sign of 4, or can be a sign of x, or can be a sign of the whole fraction negative of the fraction 4 over x. And then copy 2x minus 1, which is also not cancelled out, so it stays there. Okay. Again, I was saying negative 1 can be a sign of 4, can be a sign of x, or can be a sign of the whole fraction. Okay. Number 6. This is a case of a negative 1 factor. Let's try ab minus a squared over a squared minus 1. The whole expression is divided by a minus b all over a squared plus 2a plus 1. Same rules. Flip your second fraction and then change division into multiplication. Now, on this side, we will just factor out a, so you have b minus a. On this side, this is supposed to be a plus 1 times a plus 1. If you perform FOIL, a plus a is 2a. That's why there's a middle term of 2a. Okay. Now, that's your a plus 1, a plus 1, a plus 1, and then here you have a plus 1, a minus 1. That was the difference of two squares, because a squared is a perfect square, 1 is a perfect square, so this is its factor. and then a minus b copy. Now, you see how there's a blue and purple? That's now where we apply the negative 1 factor. When we take out negative 1 from b minus a, the a now becomes positive, the b becomes negative. Just remember, when you factor out negative 1, the term changes sign. A becomes positive, b becomes negative, and so there it is. And so we can now cancel the a minus b. We can also cancel the a plus 1, and the negative 1 can be a sign of a. We cannot perform factoring negative 1 here because it should be a switch of sign. To be able to perform a negative factor, a here should be a negative. Negative, positive, positive, negative, then we can apply. Since they are both positive, only one has opposite sign, we cannot apply the negative 1 factoring. And that's already your final answer. Okay? Remember to write negative 1 when dividing out factors that are opposite of each other. It may be written in the numerator or the denominator, but not both. What it's trying to say is that if we did not do the factoring of negative 1 here, we could have done it here. Okay? But sometimes it doesn't work. So see which one works and see which does not work. Give it a try. Okay? So this was the case of a problem that requires negative 1 factor. Just remember, let's have another sub-example here. Let's say you have x minus y. If you are going to factor a negative 1 here on x minus y, you just switch the sign. Y becomes positive, x becomes negative. Switching places does not matter as long as there is a change of sign. Okay, that's what happened here in your b minus a. This was originally the expression b minus a, and then b minus a was factored out with a negative 1. Okay, another example. This is not anymore example, this is try on your own. If you're watching this video on your own, you can pause the video, give the problem a try, and then click play to check if you got the correct answer. And the correct answers are, for the first problem, it's 4/5. The second problem is x minus 1 all over 6x squared. Okay? Remember, to multiply rational expression, factor and cancel where possible, then multiply numerators and denominators. When you divide, rewrite the problem as a multiplication problem with the first expression times the reciprocal of the second expression. Then, factor and cancel where possible, multiply numerators and denominators. There's a note here. If you need, you can define x values for which the expression is undefined. Like for example, if you have 2 over x, x cannot be equal to 0 because it will make the fraction undefined. Any number but not 0. Okay? If you need to review, you can watch this video again. Thank you. Don't you think the background music sounds good? Sounds cool? It's a natural stormy night. Thanks for watching.